Today at Flipping Science we're going to be looking at finding the formulae of ionic compounds given the ions that make up the ionic compound. To start with, we're going to look at some of the positive ions that you might come across when we're doing this. We've got some examples here. We've got sodium ion, magnesium ion, ferric ion, manganese ion, potassium ion and the ammonium ion. Notice that they have different charges, and we'll talk about where those charges come from in a second. We've also got a very interesting ion down here, the ammonium ion. That's a compound ion. It's made up of more than one element stuck together. So where do we get those charges from? If we look at the periodic table, we can see where we get these charges from for the most part. If we look at sodium, sodium's in group 1 over here. That means it gets a charge of +1. The reason for that is it has one electron in its outermost shell, so it loses that when it reacts. If we look at magnesium, the magnesium +2 ion, it's in group 2 over here. So when it reacts, it loses 2 electrons. Things get a little bit more complicated with the ferric ion. Iron is a transition metal, which means it has electrons scattered between a few different shells in its outer shell. So in this case, we're looking at the ferric ion, that makes a +3 ion. Manganese, similarly, is a transition metal ion for the manganese here. Find it on the periodic table. Here's manganese. It gets a charge of +2. Some of these you're just going to have to learn and remember. Potassium, we looked at before, group 1, so it gets a charge of +1. Then when we get to our compound ions, again, it's easier just to sit down and learn the charges of the compound ions that you need to know. And I'll go through which ones you need to know in class. If we look at some negative ions now, so some examples of negative ions, we have the chloride ion, the oxide ion, nitride ion, phosphide ion. Then we've got 2 compound ions, the NO3-, that's nitrate ion, and the SO4-2-, that's the sulfate ion. So where do we get the charges of those? Go back to our periodic table again. If we look at chloride, we can find chlorine. Chlorine's in group 7 over here. That means it needs to gain 1 electron to get a stable octet, and that means it gets a charge of -1. If we look at oxide ion, we find oxygen on the periodic table. It's in group 6. That means it needs to gain 2 electrons to complete its octet. So that gives it a charge of -2. If we look at nitride and phosphide ions, they're both in group 5, which means they need to gain 3 electrons to get them to that stable octet. So that gives them a charge of -3. Then again, I've got some compound ions over here, nitrate and sulfate. Again, for those, it's just easier to sit down and learn them. Make some flashcards. It's a good way of doing it. So now we're going to look at how you figure out how to make an ionic formula, given the 2 ions that are going to make up the ionic compound. So, 3 fairly simple things to do. Write the symbol with the charge above, crisscross the charges, then you remove any 1s, remove any charges, and you use the smallest ratio of positive to negative ions that you can. So that's how we do it. Let's have a look at some examples now. I'm going to pick a positive ion, just at random from my list, so I'll choose sodium. So we write down the symbol. I'm going to write the charge above. So sodium +1. I'm going to put +1 above. Then I'm going to select a negative ion at random. I'm going to pick the oxide ion, O2-. So write down the O, and I'm going to do -2 above. Now we need to do the crissy-crossy of charges. So I'm going to take the +1 from over here and put it next to the O. I'm going to take the -2 from over here and put it in front of the put it behind the Na. So crissy-crossy the charges. And now if I write it out, I have Na -2, O +1. Next thing we do, we get rid of the charges. And another thing we do, if you see any 1s, we get rid of those. So now if I write it out, I have Na2O, which is the formula of sodium oxide. All we've done here is basically figured out how many sodiums we need to balance the charge of the oxygen, the oxide ion, and vice versa. So how many oxides do we need to balance the charge of the sodium? That's all this process does. Let's look at another example. So I'll go back to my positive ions. This time I'm going to select the ferric ion, Fe3+. So, write down the symbol, write down the charge, 3+. Then I'm going to select a negative ion. In this case, I'm going to select the nitride ion, down here. So we're going to select the nitride ion. So I'm going to write the symbol, and the charge on top is 3-. Now I do my crissy-crossy. Write it down again. So I've got Fe minus 3. I'm just going to change the minus and the number around. N plus 3. Now, next step, get rid of the charges. Put Fe3, N3. Now, my ratio of ferric ions to nitride ions is 3 to 3. We need to simplify that and bring it down to the lowest number. 3 to 3 is the same as 2 to 2, which is the same as 1 to 1. So in this case, because the lowest ratio is 1 to 1, all I need to do is write out the symbols together. So Fen. So ferric nitride, the formula for ferric nitride is Fen. That means because they both have the same charge, those charges cancel out and they stick together. This time I'm going to use a more complicated example. I'm going to use my compound ions. So I'm going to do my positive ions sheet. I'm going to use the ammonium ion, NH4+. So I'm going to write that down, symbol NH4, and the charge on top, +1. Then I'm going to use, from my list of negative ions, the sulfate ion down here, so SO4 2-. So write it down, SO4, I'm going to use -2 at the top. I'm going to do my crissy-crossy. So now, if I write it down, I've got NH4, I'm bringing the -2 down here. Now, I've got all the numbers down here, and that makes it a bit complicated. So what I'm going to do is I'm going to put a bracket around the NH4, so I know that it means I have to have 2 of those. Then if I look at the SO4, I've got SO4, bring down the +1, so +1. And again, because it's a compound ion, it's easy just to shove everything in a bracket. We can get rid of the bracket later if we don't need it. Get rid of the charges. So now my ratio of ammonium to sulfate is 2 to 1. Get rid of the 1 because I don't need that, and because I don't need that, I don't need the brackets. So now write it out again. NH4 to SO4. So, because ammonium has a +1 charge, sulfate has a -2 charge, I need 2 ammonium ions to balance the charge of the sulfate. So, the formula for ammonium sulfate is NH42SO4. We're going to do a whole heap more examples in class, but basically that's how you write an ionic formula given the ions that make up the ionic compound. That's it for Flipping Science today. See you later.